Hey everybody, and welcome to chemistry for the spring of 2014. I'm sure Cornick already gave you the spiel as to why he does these flipped lessons, so I'm not going to really get into that much of it, but I'm going to kind of go over like the layout of what these notes are going to look like and kind of give you some hints and some tips and some pointers as to how you should maybe take notes to organize yourself. First of all, I'm not going to collect notebooks at any point in time or check your notes. You are all, or for the most of you all, upperclassmen. Wyatt, Jorge, and Morgan, sorry, you're still lowerclassmen. But the rest of you are upperclassmen, so you should be able to figure out how to take notes, right? And I'll encourage you all to take notes as best you can, to ask questions about notes when you have questions, when they do arise, and to try, don't skip any videos. It's not a good idea, okay? Just to start out quickly, bring up a piece of notebook paper here. What I would do if I was organizing these things, I would use a different piece of notebook paper for every section or a unit that we're doing. First thing I would do is take the unit, toss it in the heading right there, so toss it up top, and then I would probably take the section, so this is always going to be the section that we're talking about, and I would toss that right there, be like on my first line, maybe center it in the page. Okay, and then I'd put, the subsequent notes down below that. Whatever technique you have that you think is valuable, go with that technique. Also, like I said, probably one notebook page per section. Toss the date up in the upper right-hand corner. It usually kind of helps you remember like the sequencing of the particular unit that we're in. All right, enough about note-taking and how to take notes. This first unit is called the physical properties of matter, and we're in this first section, 1.1, we're going to talk about mass and matter. So we need to understand what mass is and the different types of matter that make things up. Okay, let's get to it. Okay, matter. Let's get a definition. First of all, matter is the stuff of which the universe is composed. So if you look around you right now at your computer or wherever it is that you are sitting, and you look at your pencil and your notebook paper, and even the air that's floating around you and the little air molecules are hitting you in the face really hard, they're traveling at like 1,300 meters per second, which is really fast. All of that stuff is matter, okay? And that's really chemistry in a nutshell. It's the study of matter and the changes it undergoes. So we're going to hear this term matter a lot. All right. Two things about matter. First of all, it has mass, and second of all, it takes up space. So anything that has mass and takes up space is called matter. I encourage you to try to think of something that doesn't fit that definition. Feathers, matter. Bowling balls, matter. Arrows, matter. Orange juice, matter. See, everything is matter, right? Light. What about light? Oh, interesting. We'll get to that later. So what's it made out of? Well, matter's made up of atoms. I'm sure you know this from previous courses. That's why I'm going to go quick today. And atoms are defined as the fundamental unit of which matter is made. The fundamental unit of which matter is made. So we really have two definitions on this page, right? You'll notice that my definitions are underlined. Sometimes I'll highlight them. Sometimes I forget. I'll grant you that. And then their definition is typically always going to be in italics there and there. Okay? So we think of atoms, we usually think of something like this, right? That's kind of like the model atom. And that's good. That's a neat representation. So is this actually what atoms look like? No, but it is a model. And actually our course, our chemistry course at Reedsville, is taught via a modeling method. So we use models to try to teach everything. And models are great. They give us kind of how the atom looks and how it interacts and where the particles are. But there's some misconceptions and there's some places where the model kind of breaks down. For our purposes, though, the model of the atom, as you see in front of you, is pretty darn good. This is actually what atoms look like. These are actual nickel atoms. We have some instruments like an electron tunneling microscope that can actually see atoms now. That's the technology that we have developed. That's pretty cool stuff. Okay, pretty neat stuff. The blue that you see, if you're curious as to like what the heck is this picture, each one of these little bulbous things is an atom, and the blue you see is kind of like the electron cloud. So the electrons are spinning around there, and if you could imagine the center of that little bulbous thing would be the nucleus. I'm sure electron cloud and nucleus, you've heard those terms before. All right, so atoms by themselves, relatively boring things, but we need to talk about them nonetheless. Not all atoms are really created equal, unlike the Constitution, and it states that All men are created equal, right? And ladies created equal as well. But not all atoms are created equal. All matter is really composed of about 100 different types of atoms. Different. And how do they differ? Protons, neutrons, and electrons, right? The guts of the atom. You know, that's what makes each one of these atoms specific and unique and different. So that's the difference there. Elements are really what we define as the atoms. Elements are just substances containing one type of atom. So if you think of carbon, best representation I could tell you is like charcoal. When you're grilling out in the summer, charcoal. Think of that piece of charcoal is just a bunch of different types of carbon atoms strewn together. And all those atoms are pretty much the same. The only difference being some might have one or two more neutrons than others. But for the most part, they're the same, okay? So that little chunk of charcoal is made out of one element, and that element is carbon, and carbon is composed of a bunch of different atoms. Now, most of the universe, most of the things that you see around you, the computer in front of you, and the hair on top of your head, and the clothes you are wearing, most of the universe is composed of combinations of these elements, just not one specific element. And we call these combinations of elements, we call them compounds. Compounds are substances made by combining atoms together in specific ways. And later on in future chapters, we'll get more into depth about elements and compounds and molecules and all that minutia. Right now, we're just kind of laying the framework and the groundwork for the beginning of our chemistry journey. So we've got elements, we've got compounds. Okay? All right, now let's just do some visual here real quick. When we talk about elements, we might be familiar with these guys, right? These we would find on the periodic table. All right, these are chromium and zinc and magnesium, calcium, iron, sodium, selenium, copper, and fluorine. These are all different types of atoms, and they're each specific elements. Got it? Great. Okay. But we can take these elements and we can combine them. So we can take one atom of hydrogen and another atom of hydrogen and stick it together and make a hydrogen molecule. Or we can get a little bit more crazy and take two hydrogen atoms and one oxygen and stick those together and make a water molecule. Oh my goodness. Or two oxygen atoms and a carbon atom and make a, breathe out, carbon dioxide molecule. There it is. Super. So we can do all these crazy combinations. So these are some simple compounds that you see here in the upper right-hand corner. But we can get a lot more technical and difficult than just the compounds in the upper right-hand corner, because what would chemistry be without some explosions? And we can make this particular molecule in the lower left-hand corner, and it's known as trinitrotoluene. Its shortened, abbreviated version of its name is TNT. By the way, TNT and dynamite, not the same thing. Sorry, AC/DC, your little song that you have. They're not the same thing. They're a little bit chemically different. But there you go. That's trinitrotoluene, or TNT. And you can see that it's just a combination of different atoms. Again, this is a model that you see here in the lower left-hand corner of the screen. It's a model of what the molecule would look like. And each one of those spheres that you see in there represents a different atom. The black ones are carbon, and the white ones are hydrogen, and the blue ones are nitrogen, and the red ones are oxygen. Okay, so that's TNT, and the middle one here is something you're very, very familiar with. It's acetaminophen. You might not know that name, but you sure know the name Tylenol. The active ingredient in Tylenol is right there in the middle of the screen for you. And then on the right side, you have my favorite molecule of all time. That is caffeine. And as I sit at my desk, I'm looking at it. It is right above my head, hanging from the ceiling. You all can see it when you come back to class on Monday. So there you go. That is your first flipped video for chemistry class, and we made it under 9 minutes.